Section 7.5, Solving Trig Equations. In this section, you will solve trig equations that are linear, quadratic, and also solve equations using fundamental identities and solve trig equations with multiple angles. This section is like a capstone of the entire trig part of our class. We will use all the trig that we have learned to help us solve trig equations. Then in section 7.6, we will solve application problems using all our skills as well. The easiest problems are those that only have powers of 1. Let's say, for example, number 1, find all the solutions to cosine theta is equal to 1/2. And take note of this, we want to find all the solutions. So cosine theta is equal to 1/2. And if you want to get the inverse both sides, so that will be theta is equal to inverse cosine of 1/2. All right, let's use our unit circle. So we know that here at pi over 3, the coordinates are 1/2 and square root of 3 over 2, and this is cosine. Same thing with 5 pi square root of 3, because the coordinates are 1/2 and negative square root of 3 over 2. So this is also cosine. So theta, you can say that theta is equal to pi over 3 and 5 pi over 3. But since we want to find all the solutions, so our solution set must be, we have two answers. So theta 1 is pi over 3 plus 2 pi k, and the second one 5 pi over 3 plus 2 pi k. That is where k is an integer. Okay, next example number 2. Again, find all the solutions to sine t is equal to negative 1/2. So let's do the same thing like what we did for example number 1. So you could say that t is equal to inverse sine of 1/2. In a unit circle, pi over 6 and 5 pi over 6, that is where sine is positive 1/2. So that's why our answers t1 is pi over 6 and 5 pi over 6. And again, since we want all the solutions, so we add 2 pi k plus 2 pi k, because we know why 2 pi k, why 2 pi, because 2 pi, that means that is 1 period. And remember that k is an integer. Means, take note of this, that in general, for all solutions, we need to write theta plus 2 pi k. Okay. Next example. Solve the equation on the given interval from 0 to 2 pi of tangent theta minus pi over 2 is equal to 1. Do the same thing like what we did for examples 1 and 2. We get the inverse tangent both sides. So that's why this will be theta minus pi over 2 is equal to, what is inverse tangent of 1? A unit circle, we have pi over 4, that the coordinates square root of 2 over 2 and square root of 2 over 2, because we know that tangent theta is sine over cosine. This is cosine and this is sine. When we divide these two is equal to 1. Same thing here. This is cosine and this is sine. When we divide these two, negative square root of 2 over 2 over negative square root of 2 over 2 is equal to 1. So meaning the first one is pi over 4. So we're using this first one, pi over 4. So let's say this is theta 1, and then we can solve this. So if we add pi over 2 both sides, we will have pi over 4 plus pi over 2 is 3 pi over 4. Then the other one, theta 2 minus pi over 2 is equal to, the second is, from the unit circle we have 5 pi over 4, and then if we add pi over 2 both sides, so that we will have 5 pi over 4 plus pi over 2 is 7 pi over 4. So our solution set, we have 3 pi over 4 and 7 pi over 4. Okay, all right. Next, example number 4. This time, solve the equation on the given interval from 0 to 4 pi of cosecant theta is equal to negative 2. So cosecant theta is equal to negative 2. And using the reciprocal identity, cosecant theta, we know that this is 1 over sine theta is equal to negative 2. And if we cross multiply this, 1 is equal to negative 2 sine theta. And if we divide both sides by negative 2, so we will have sine theta is equal to negative 1/2. And then if we want to get the theta, we want to get the inverse sine both sides. So that we have theta is equal to inverse sine of negative 1/2. Again, let's use our unit circle. We have negative 1/2 for 7 pi over 6 and 11 pi over 6. So that's why we have here the first one 7 pi over 6 and the second 11 pi over 6. But take note, it says here that solve the equation on the interval from 0 to 2 pi. So meaning that is with 2 rotations. So all we have to do is add another rotation, so another period, which is 2 pi for both. So 7 pi over 6 plus 2 pi is 6 times 2 is 12 plus 7, that is 19 pi over 6, and 2 times 2 is 4 plus 11, right, again 6 times 2 plus 11, that is 23 pi over 6. So this is our solution set. Right, next, example number 5. Solve the equations on the interval from 0 to 2 pi that are a t cosine theta minus 3 is equal to negative 5. So here are the steps to follow. So the first one, isolate the trig function and then inverse trig both sides. So letter A, so isolate cosine theta. So we need to add 3 both sides. So 2 cosine theta negative 5 plus 3 is negative 2. Then divide by 2. So cosine theta is equal to negative 1. And then inverse trig both sides. So theta is equal to inverse cosine of negative 1. And that is equal to pi. A unit circle here at pi, cosine here is negative 1. So that's why our answer is pi. So the solution set is pi. Okay, letter B, let's do the same thing. Isolate the trig function, isolate sine. So that is subtract 4 both sides. So sine theta is equal to negative 6. Then divide by 2. Sine theta is equal to negative 3. And then inverse trig both sides. So theta is equal to inverse sine of negative 3. Note that in a unit circle, that is from negative 1 to positive 1, and this is inverse sine of negative 3, so that is out of range of sine of theta. So we can say that there is no solution. Okay. Next one, solving trig equations that are quadratic. When there is a trig function that has a power of 2 or bigger, then we must solve the equations differently. Like example number 6, solve the equation on the interval from 0 to 2 pi, and given 2 sine squared theta minus 1 is equal to 0. Isolate the trig function, the sine theta. So first we add 1. So 2 sine squared theta is equal to 1. Then divide by 2. So we have sine squared theta is equal to 1/2. And then square root both sides. So we will have sine theta is equal to 1 over square root of 2. So minus, and if we simplify 1 over square root of 2 to rationalize the denominator, so 1 over square root of 2 multiplied by square root of 2 over square root of 2, that is square root of 2 over 2 times 2 is 4, square root of 4 is square root of 2. Then inverse trig, inverse sine, so that theta is equal to, let's use a positive first, of square root of 2 over 2. And in a unit circle, square root of 2 over 2 sine, that is going to be pi over 4 and 3 pi over 4. The other one, inverse sine of negative square root of 2 over 2. So we will have 5 pi over 4 and 7 pi over 4. Example 7. Solve the equation on the interval from 0 to 2 pi. This time given 2 sine squared theta minus 5 sine theta minus 3 is equal to 0. Let's say let u is equal to sine theta. So we will have now 2u squared minus 5u minus 3 is equal to 0. And the factors of this, 2u squared, 2u times u, and then 1 minus 3. 1 times negative 3 is negative 3. 2 times negative 3 plus 1 is negative 5. Then set each factor to 0. Then solve for u. So here u is equal to negative 1/2 and u is equal to 3. And don't forget we use u equals sine theta. So we have these two values of u. So sine theta is equal to negative 1/2. Inverse trig both sides. So inverse sine of negative 1/2, and that is 7 pi over 6 and 11 pi over 6. The other one, sine theta is equal to 3. That is when u is equal to 3, and inverse sine of 3, and that's outside the range of sine, so meaning there is no solution here. Okay. Next, we can also use any of the identities that we know to help us solve equations too. Like example number 7. Solve the equation on the interval 0 to 2 pi given sine squared theta is equal to 2 cosine theta plus 2. With this, I use identities when you have more than one type of trig function. Just like here we have sine, cosine, then use identity on the trig function that is higher power, like sine squared theta. And we know the Pythagorean identity that sine squared theta plus cosine squared theta is equal to 1. So we can say that sine squared theta is equal to 1 minus cosine squared theta. Let's use this to substitute to the given. So 1 sine squared theta is 1 minus cosine squared theta is equal to 2 cosine theta plus 2. We can make this the left side 0, so subtract 1 and add cosine squared theta to both sides. So that you'll have 0 is equal to cosine squared theta plus 2 cosine theta, and 2 minus 1 is 1. And now you can use let u is equal to cosine theta, so that this is u squared plus 2u plus 1 is equal to 0, and the factors are u plus 1 and u plus 1, so that u is equal to negative 1, and we'll use that here. Let u is equal to cosine theta, so cosine theta is equal to negative 1, and then inverse cosine of negative 1, and that is going to be pi. So the solution set is pi. Right, next example 8. Use the difference formula to solve on the interval from 0 to 2 pi cosine x cosine 2x plus sine x sine 2x is equal to square root of 3 over 2. So again, using the difference formula, here you can say that alpha is x and beta is 2x. And just to recall our difference formula, cosine alpha minus beta is equal to cosine alpha times cosine beta plus sine alpha sine beta. So here it is your alpha, beta, alpha, beta. So we can say that this is cosine of alpha minus beta, that is x minus 2x, is equal to square root of 3 over 2. And x minus 2x is negative x is equal to square root of 3 over 2. Of negative x, that is cosine of x is equal to square root of 3 over 2. Then inverse trig both sides, so that x is equal to inverse cosine of square root of 3 over 2. And using the unit circle, that's gonna be your x is pi over 6 and 11 pi over 6. Unit circle here, pi over 6, that is your cosine is square root of 3 over 2. And also 11 pi over 6, cosine is square root of 3 over 2. So that's why we have the two answers, pi over 6 and 11 pi over 6. Next, example number 9. Solve the equation exactly using the double angle formula given cosine 2 theta is equal to cosine theta. Using double angle formula, recall that cosine 2 theta is equal to 2 cosine squared theta minus 1 and equals cosine theta. And then if we subtract cosine theta both sides, you'll have 2 cosine squared theta minus cosine theta minus 1 is equal to 0. And let's say u is cosine theta, so we will have 2u squared minus u minus 1 is equal to 0, and factors are 2u plus 1 and u minus 1 is equal to 0, so that u is equal to negative 1/2 and u is equal to 1. We use u is equal to cosine theta, so cosine theta is equal to negative 1/2. So inverse cosine of negative 1/2, and that is equal to 2 pi over 3, and the other one is 4 pi over 3. And also, when u is equal to 1, let's use this space here, so that is cosine theta is equal to 1, theta is equal to inverse cosine of 1, and that is equal to 0. So our answers 2 pi over 3, 4 pi over 3, and 0. And you may ask about how did I get cosine 2 theta is equal to 2 cosine squared theta minus 1 is this. So recall our double angle formula. Cosine 2 theta is cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1, and we used this one, 2 cosine squared theta minus 1 here. Okay, next, solving trig equations with multiple angles. So finally, when there is an angle like 2 theta or pi theta over 2, we'll have to modify our method to get the solutions. So let's say example number 10, solve the equation on the interval from 0 to 2 pi given cosine 2x is equal to 1/2. That is example number 10. So cosine 2x is equal to 1/2, and if we get inverse cosine both sides, you'll have (2x) is equal to inverse cosine of 1/2. And what is inverse cosine of 1/2? The unit circle, cosine pi over 3 is 1/2, and cosine 5 pi over 3 is also 1/2. So we can say that 2x is equal to pi over 3, and 2x is equal to 5 pi over 3. And if we divide both sides by 2, we will have x is equal to pi over 6. Same thing here, divide by 2 is equal to 5 pi over 6. And we're not done yet because we want to get all the solutions. And take note of this, this is cosine 2x, and that is from 0 to 2 pi, so that is over rotation. So meaning a period of cosine, we would need to add the first one, 2x is equal to pi over 3 plus 2 pi. Also 2x is equal to 5 pi over 3 plus 2 pi. Change this to 2x is equal to pi over 3 plus 6 pi over 3, so that they have the same denominator of 3, and divide both sides by 2, so that x is equal to pi over 6 plus 6 pi over 6, and that is 1 plus 6 is 7 pi over 6. So let's do the same thing for the last one, 2x equal to 5 pi over 3 plus 2 pi. You can write this as 2x is equal to 5 pi over 3 plus 6 pi over 3, and then divide both sides by 2, so that x is equal to 5 pi over 6 plus 6 pi over 6, so that we have 5 plus 6, 11 pi over 6. And as you can see, 7 pi over 6 in a unit circle here, this is 7 pi over 6, and this is 11 pi over 6. And we got all this because we want to solve the equation within the interval from 0 to 2 pi, and all of these 4 are within 0 to 2 pi. So get all the solutions. Okay, so that is example number 10. Now let's try some lecture questions. Number 1, for the following exercises, find all the solutions on the interval from 0 to 2 pi. Letter A, 2 sine theta is equal to negative square root of 2. So remember, isolate the trig function, isolate sine, so divide both sides by 2. So sine theta is equal to negative square root of 2 over 2, and then inverse sine both sides, so that's going to be inverse sine of negative square root of 2 over 2. And then check your unit circle, and inverse sine of negative square root of 2 over 2 is equal to 5 pi over 4, and 7 pi over 4. Okay, let's do the same thing for letter B. So isolate sine, so add to both sides. 4 sine squared x is equal to 2. Then divide both sides by 4, so that we have sine squared x is equal to 1/2. Then square root both sides, So we will have sine of x is equal to plus or minus 1 over square root of 2. And remember, to rationalize this, that becomes square root of 2 over 2. Positive and negative. So let's start with the positive. Then inverse sine both sides. So inverse sine of square root of 2 over 2. And remember, this is equal to pi over 4 and 3 pi over 4. Then the other one, negative square root of 2 over 2, inverse sine both sides. So that it is 5 pi over 4 and 7 pi over 4. Okay. Alright, next, number 2. Use trigonometric identities and algebra to solve on the interval from 0 to 2 pi, letter A, sine squared x plus cosine squared x is equal to 0. This is one of the easiest. If you remember, by using Pythagorean theorem, Pythagorean identity, that sine squared x plus cosine squared x is equal to 1. So that means this sine squared x plus cosine squared x is equal to 1 equals 0, and 1 is not equal to 0. So we can say that there is no solution. That is for letter A. B. Sine 2x is equal, sine 2x minus sine x is equal to 0. So sine 2x, so using the identity, just to recall, sine 2x is equal to 2 sine x cosine of x. So let's use that. So sine 2x here, replace it with this. So 2 sine x cosine x minus sine x is equal to 0. We can factor out sine x here. So we have here 2 cosine of x minus 1 is equal to 0. And then, since we have these two factors, we can set each factor to 0. So sine of x is equal to 0, and 2 cosine of x minus 1 is equal to 0. So here we can solve for x, sine x, so that is inverse sine both sides, and inverse sine of 0 is equal to 0 or 2 pi. So just to recall, using a unit circle of 0, the coordinates here 1 and 0, sine here is at 0, this is at 0 and 2 pi. Okay, the other one, 2 cosine x minus 1 is equal to 0, add 1 both sides, So 2 cosine of x is equal to 1. Then divide by 2. So cosine of x is equal to 1/2. And then inverse cosine. And in a unit circle, cosine of pi over 3 is 1/2. And cosine of pi over 3 is also 1/2. So we can say that our x is equal to pi over 3 and also 5 pi over 3. Okay, so these are the answers for this problem number 2, letter B. Okay, so that's it for section 7.5. Let me know if you have any questions, and thank you.